Section 2.5, transformation of functions. There are several functions that are very common to use when you come to translation of the functions. One is y equal x to the power of 2, and which is like a half a bowl. The other one is y equal x to the power of 3, which is the odd functions. This one is even. That's why you see it, all the y is always positive on it. And then y equal radical x, which is like a half curve. Y equal absolute value of x. So we do a lot of translations on this. Translation means you could have transformations on the y-axis, on the x-axis, and so on. Now here, they show you a couple of good examples in the textbook. Like, excuse me, like how do I graph y equal x2 plus 2? This is the original functions. Original function is y equal x to the power of 2. When you have a number, add or subtract to these functions, that would be a shift on the y-axis. So plus 2 means you take these functions and you shift it up. The whole thing, you shift it up 2 units. So from here, 2 units, you shift it up. When you have a number within the parentheses associated with the x, then the shift would be on x-axis. And like if you have x minus 2 here, that means the shift is always opposite of the sign that you have here. Like x minus 2 means x is 2. X is 2 means the original function, which is y equal x2, you shift it to the right. You shift it to the right 2 units. See, like this point shift to the right 2 units. So you either have number outside of this functions or within in the parentheses with that function. So that's the main difference between these two. So again, this would be shift positive 2 means on the y-axis, and within the parentheses is opposite of sign that you have here. And they all explain here that when you have a function and there is a number associated outside of that, if it's positive, you shift it on the vertical, on the y-axis, positive, or shifted up. Here is shifted down. When it's in the parentheses, is opposite. When it's x minus c, means x has to be equal to c, means there is a shift to the right, shift to the left. And then here, there are another example, and that's basically a function of y equal x3. Function of y equal x power of 3 is this functions. The number is outside, which is negative 1. Negative 1, which is outside of this function, means you shift it down. You shift the whole thing. You shift this down 1 unit. 1 unit. So if it's 0 now, it's negative 1. See? You shift the whole thing down 1 unit. And if the number is inside of the parentheses, okay? So these are a combination of two translation. The original function is y equal x2. Let's say if this is y equal x2, when we ask you to do y equal x plus 2, I'm sorry, this is the power of x plus 2 to the power of 3, means you take the functions. This is the functions, right? X equal x3. You shifted negative. See, x plus 2 is 0. X is negative 2, means you have to shift it on the x-axis to the left 2 units. So this point would shift 2 units here. Every point shift 2 units, okay? And then when you do that, then there is another shift to the new function. There is another shift to the new functions, and that shift is positive 1 now. So now you have to take the new functions and shift it on the y-axis 1 unit. On the y-axis 1 unit. See? So the whole thing move up 1 unit. So there are two translations, two transformations here. Y equal x3, first you move it, and then you move it up. See this point? Because of this -2, you shift this point 2 units here, and because of this one, you shift it up 1 unit. So this point actually now is here somewhere. Okay, and this is the same thing for other ones. Now, you also have reflections. If the negative is outside the functions, is reflection on the x-axis, and if it's within the functions or within the parentheses, is on the y-axis. For instance, here, look, y equal x4. Y equal x4, this is a problem. It's very similar to y equal x2. So this is y equal x4, right? And now, how do I graph minus x4? Minus, when you have a negative outside of the function, minus x4, then you reflect it on the y-axis. Okay? So, and then you have +2. So these functions would reflect like that first. Okay, so this function, excuse me, y equal x4, if you want to do y equal minus x4, then it would be this. And then because of the +2, you shift this function up to get that one, see? It gives you a new function. So this function, they call it g of x. So you graph x4 first, then minus x4 is this. Then minus x4 plus 2 means you take these and shift it up 2 units, which give you that. Okay. Now on this one, the shift is, number is inside of the parentheses. So shift would be positive. See, x minus 3, so x equal 3 is always, when it's in the parentheses, always opposite sign. So if it's -3, it's +3. So you shift it to the right. So let's say you did this part, right? And then, so here, I have y equal x4. Then y equal minus x4. And now y equal minus x minus 3 to power of 4. So now this one, now there is a shift of 3 units. So this one should shift to the right 3 units. See? That's how you do it. 2 reflection. One is reflection toward y-axis, then shift to the right 3 units. That would give you this one. All right. This is also about the radical x. If the negative is outside, is reflection is like that. If the negative is inside the parenthesis or here is under the radical, then that's how you had it. Here. And then the last one would be to shift, means now you take this one or this one, and then you shift it, because positive you shift it negatively. So this goes to the left. Okay. So for the last one, look, you have y equal radical x, correct? And now is minus radical x. So from here would be this. This is radical x. This is minus radical x. And then this one Means now you have to take this and shift it -2. So this one, you shifted -2. So this point is shift to the left -2. So that would be y equal minus radical x plus 2. So radical x minus radical x would be reflection with respect to x-axis, or so it would be like this. And then because of the -2 opposite, see under the bracket, under the radical means like inside the parentheses, shift is always opposite of the sign that you have. +2 is -2. This is also about the radical x, you know, all the shift about the radical x. Okay, so now most of the homeworks are about, you need to find right pictures like here. Radical x plus c, plus a number. That could be any number, constant. So this is a shift on what? On the y-axis. See? Like, what is the radical x plus 2? Means you take the radical x and shift it up 2 units. Or what's the radical x minus 3? You shift it down -3. See? That would be the right ones. If this is original functions, what if you have negative? When it's a negative, means it's the shift. If it's inside the parentheses, the reflection would be on the x-axis, okay? So the whole thing would move with the reflections. You respect that. +4 means you shifted up 4 units. So that would be this one. This was the original functions. +4, you shifted up. You shift the whole thing up. So if you go through these pictures and based on that, you should basically understand all this. What if you have like something like that, 2f of x? I'll show you an example here. What's the difference between y equal x2 and y equal 2x2? The only difference is, it's kind of skinnier. The graph is skinnier here. Look. When you go from x2 to 2x2 or 3x2, 4x2, is, you have, for the same value of x, you get a larger value of y. So the graph becomes skinnier. That's all. So here, it was 2f of x, right? Means your original functions say this is the original function, right? The value of y double. See? 2, now it's 4. -4 is -8. -4 is negative. So what's the difference between f of x and 2f of x? Every value of y doubles. Every value of y is double. This is in case you have 2 shifts, right? One is reflection. There's a reflection with respect to the y-axis, and then -4 means you get a shift positive. So +4, you shift to the right. All right, so there are so many graphs here. I'll let you go through it and yourself based on all those translations. And also, if you use a graphing calculator, if you know the actual function, the calculator would give you that. All right. Like this kind of problems, identify the pattern function. What function did you have originally in order to have? So the original function was radical x, right? And if I have x minus 7, then we have this one, which we call this a new function. We call it like g of x. Just put a name for it. That's what they're asking. Okay. All right.